Okay, year 12 further mathematicians, we're going to move on to 11.3 trigonometric identities. So for today's integrations, before you can do them, you might have to use some of the identities. So, can you remember the identities? That is the question. So a couple of ones which you definitely need to know is the Pythagorean identity, that's the fancy word for it, which is just sine squared theta plus cos squared theta is identical to 1. And also tan theta is sine theta over cos theta. Now, you can get two more identities from this. You can get, if you divide everything by sine squared, you'd get 1 plus cot squared theta is identical to cosec squared theta. And if you instead divided that initial thing by cos squared, you'd get tan squared theta plus 1 is identical to sec squared theta. If you flip everything around in this, you'll get cot theta is identical to cos over sine. But then some of the ones I'm more interested in today, some of the double angle formulas. So you should know one for sine 2 theta. That's identical to 2 sine theta cos theta. You should know one for cos 2 theta. That's cos squared theta subtract sine squared theta. However, there's two more for this. It's also identical to 2 cos squared theta subtract 1. Or 1 subtract 2 sine squared theta. Now there's more trig identities, but we're going to start with those, and I'm going to assume you know those when doing this exercise. Right, e.g. number 1. Okay, we've got to find the integral of tan squared x with respect to x. Now, if you look back on that 11.1 page, which was like page 294 or wherever it was on, there's nothing about integrating tan squared. However, you can rewrite tan squared into something you can integrate using one of those identities above. Okay, and it is this identity there. If you made tan squared the subject in this identity, you end up with just functions you can integrate. So this is equal to, make tan squared the subject, you'd get sec squared x subtract 1 with respect to x. I'm claiming you can integrate both of these separately. dx. Okay, sec squared. You should know that integrates to tan x. 1 obviously integrates to x. And remember the plus c. So yeah, main thing today is the initial thing you won't be able to integrate. You've got to use identities to turn it into things you can integrate. So it's a combination of knowing your trig identities and knowing which trig stuff you can integrate. Let's try and use number 2. Okay, integrate. Got a definite integration. Can't just type it into your calculator and give the answer because they'll ask for an algebraic method. A sine squared x. Now, sine squared x, you might think you can integrate because you know what sine x integrates to, but you don't. So you have to use an identity and end up with stuff you can integrate. Trig stuff to a power, very difficult to integrate by themselves. Now, if you look at the options, look at this up with the sine squared, you've got this one, but you'd end up with cos squareds. Anything else with a sine squared, this one, but you'd end up with cos squareds and cos 2 thetas. And this one, Let's try this one out. So that was cos 2 theta is identical to 1 minus 2 sine squared theta. If I made sine squared theta the subject, it'd be a half subtract a half cos 2 theta. Add, subtract, divide by 2. Right, let's replace sine squared x with that. So we have integrate between pi by 12 and pi by 8. A half subtract a half cos 2x dx. This is equal to integrate pi by 12 pi by 8 a half with respect to x, subtract integrate a half cos 2x between pi by 12 and pi by 8 with respect to x. Now you can definitely integrate this, but you're going to have to use a guess for this one. So you cos 2x, where the 2x is in the bracket, you can have a guess at. You should know that cos integrates to sine, so let's guess sine 2x. See how bad the guess is. Dy by dx is equal to, well, sine goes to cos, but you've got to remember to times by 2. So that is 2 cos 2x. We wanted a half. So the guess is out by quite a bit. So it's out by a factor of 4. So this is equal to a half, you should know, goes to a half x. This is out by a factor of 4, so my guess needs to be divided by 4. So I'm subtracting a quarter of my guess. And do I need a plus c? Not for definite integration. That's between x is pi by 12 and x is equal to pi by 8. Next thing you do is you substitute the limits in. This is equal to a half pi by 8. Upper limit in first. Always show the substitution. Subtract a half pi by 12. If you don't show the substitution, you could lose a method mark if you had made a mistake somewhere else. It's a really easy method mark to pick up. Right, type that into your calculator. So we have a half pi by 8. Just realised my calculator's in the wrong mode, so put in radians. Pi by 8 subtract a quarter sine 2 brackets pi by 8. Close the brackets, subtract a half pi by 12. Subtract a quarter sine 2 pi by 12. Press equals, and it's annoying, but didn't ask for exact answer, so I can actually give the decimal version. If you had to do the exact answer, you'd have to take it in terms of pi. So that's 0.0137 to 3SF. See if that's right. Use the integration button on the calculator. sine x squared between pi by 12 and pi by 8 okay, it's exactly the same, so we definitely did it correctly. So the only difference would be if they said the exact value, I'd have to actually use my brain in that last step. Right, e.g. number 3. Integrating sec x plus tan x all squared. Okay. The only thing I can think of is expanding the brackets, which is unfortunate. So integrate, I'm going to do the extra step because some of you will forget a couple of terms in the middle. So sec x plus tan x written out twice, and that simplifies to sec squared x 2 tan x sec x plus tan squared x dx. Now, okay, let's write these as 3 separate functions. So I'm integrating sec squared x, I can do that, plus I'm integrating 2 tan x sec x, I can do that, integrate tan squared x with respect to x, not sure if I can do that. So you should know that sec squared integrates to tan, and because there's no multiples or anything, it's just x's, you can just write the answer down. Okay, you should know that tan x sec x from that page in the book integrates to sec x. So 2 of them would be 2 sec x. Tan squared x is not in the book, but we did work it out in e.g. number 1. So I'm going to cheat and just look at e.g. number 1 again. That's what the answer was, integrating tan squared. You'd have to do the same method again, use the identity, but what's the point when I've got the answer? So it's tan x minus x. And then because it's indefinite integration, remember the plus c. You can collect some like terms actually, believe it or not. So that is 2 tan x's, because tan x plus tan x is 2 of them, plus 2 sec x, subtract little x plus c would be my final answer for that. Just going to check to see if we've got an e.g. number 4. Okay, good news, no e.g. number 4. So the questions I'd like you to complete today are as follows. So if you find page 300, exercise 11C, okay, you're going to try the following. So you're going to do question 1, but you're only going to do the first column. Remember, you've got to use your trig identities for these. Question 2, first column. Then you're going to do question 3, and one more. You're going to do question 6. So 1, first column, 2, first column, 3, and 6. Any problems with any of those, let me know on the Teams chat.